Uh, his area of interest is machine learning, deep learning, big data, soft computing, and algorithms of informatics. Sir has more than 40 plus publication in SCI, SCIE, and Scopus indexed journals. He was earlier associated with IIT Delhi for his PhD and MTech, and now he's presently working as an assistant professor in Department of Computer Science in IIT Jammu. He's having his expertise in big data analytics and machine learning. And today, Professor Jamuna Prashaji will be speaking about the role of machine learning in big data analytics. So this is really going to be a very wonderful talk, and it's the need of hour, because when we do have an abundance of data with us, and that data is of no use if we do not analyze or do not get information from the same. So that's why the researcher, the data scientists are always on the need to look into the new approaches to come out with something useful from this data. So in this regard, we had a session from Jamuna Prashaji. He will be speaking about that how machine learning can be used for big data analytics, and what are the tools and techniques like Hadoop, how Spark and Kafka, they all will be, they all are used for big data analytics in a real-time scenario as well. So nice, sir. So nice for accepting our request to be here as a speaker. And with a very short span of time, you gave your consent. That was really a wonderful from your side, sir. Please, sir, thank you very much again from on behalf of Vadava campus of University of Jammu, as well as Ramajun College of Delhi University. Once again, I welcome you, as well as I thank you. Thank you for your kind acceptance for joining as a speaker in this FTP, sir. Thank you very much, sir. Please go ahead with your talk. Please go ahead.
Thank you, Professor Sharma, and your team, and all the associated organizations, institutes who is basically in collaboration with you. And very good morning to all of you here. So in the today's talk, we are just going to give you the little bit basic concepts about ML. Then what is the basically challenges? Challenge basically in the current day, or you can in the modern day scenario, in order to deploy any machine learning or AI models. So that is of course due to the large volume of data, and though you have heard the basically phrase that machine learning models are basically hungry, right? Data hungry. But how much data these models basically need, right? So it is not like that infinite data they need, right? So they need good amount of data, of course, but you cannot say that if you have a maybe voluminous data, right, enormous amount of data, and then your machine learning model will do good. So no, it is not like that. So if you have sufficient amount of data, and the data is basically representing the distribution of whatever distribution is it's basically representing, then that data is sufficient in order to have a good model, right, for inferencing, for any type of inferencing. So in the today's talk, we will going to discuss a few the basic concepts about the ML. Then what are the challenges even in the standard ML approaches. Then we will give you the scenario. We can discuss that scenario where if you have a large volume of data, data at a scale. So how these basically AI algorithms are able to solve those sort of data, right? So because as Professor Sharma said that if you have a data, and data you do not able to analyze the data, and you do not able to get any information from the data, extract any information from the data, then the data is of no use. And sometime in addition to that, I am also adding few points. So data is okay, but if you have a bad data, so good data and bad data, so we will discuss in during our talk. So, but if you have very bad data, so basically with respect to the some task, then that data is of no use. So we need the data which basically representative of some distribution, which we basically intend to model, right? So that's the idea about the data. So that data, you can say that is the good data, and bad data is basically the data which is basically noisy, or basically does not basically have any representation of any distribution. Sometimes it may have some value in order to infer something, but for machine learning models, if you want to do some inferencing and some prediction, decision making, then your data should follow some sort of distribution. Otherwise, what happened during the test time or deployment, right? Your real data, suppose you are getting the real samples or real data points you are getting. If your model is not able to basically extract or model has not extracted the pattern from the data in order to represent its distribution, so it will not be able to generalize well, right? So in real time, it may not work well. So there are a lot of few problems are there. So we will discuss during the talk. And as we have a 1 hour of basically time span here, maybe I can go 5 to 10 minutes beyond that. We'll try to basically finish all the concepts, brief about the concepts within this time span. So I'm just going to share my slides now, and then we can move in a directed way. Sorry. So is my screen visible?
Yes, sir, visible.
Yeah. So just a minute, I'm just moving it to the full screen. I'm arranging the toolbars list. Yeah. So the outline of the today's talk is basically the process involved in data analysis. Then what are the sources of the data? So types, the types. So and in how many forms the data exist. Then what are the different problems that basically exist that we intend to solve using the AI or machine learning models to analyze the data. Basically, what are the problems and what are the algorithms exist. Then we will discuss the big data aspects. So what is big data? So I think everyone have heard the 4 V's, right? So volume, variety, velocity, and veracity. So these are the concepts if we are talking about the big data aspects. Then what are the technologies available in order to analyze the big data? So analyze, whenever I say analyze, so analyze means the very important and primary step is storing the data. So that is a basically challenging part. So once you have stored your data, and then now the task is to analyze the data. And there are some algorithms where you can do the basically your data is online streamed. So streaming online. So you have to basically analyze the data on the way, on the fly. And you just keep the meaningful data, and you just discard maybe the data which is basically not meaningful or irrelevant data you should discard. So this is basically there are two ways. One is basically static and the other one is online. So in static, or you can say the offline way, you have to store the data somewhere, then you have to analyze it. And in online setting, it is basically the on the fly concept. So you are streaming the data, and during the streaming you are doing some analysis with the data, and just storing or extracting the features, or you can say the pattern from the data in order to do further inferencing. Then frameworks, we will discuss the MapReduce architecture, and if time permits. And I will also showcase you the IIT Jammu infrastructure that we have here regarding this big data, private cloud, and HPC. And then if, some demo, we will try to illustrate some demo, right? Okay, so here the first slide is very informative. I think from this, started. I think FDP started from 16 to 20, schedule is 16th January to 22nd January, right? So during that time, I think 16 to this today, right? 19. You have heard about the machine learning and what is the definition of machine learning, what is the task of machine learning AI, right? So here I'm just giving you a little bit brief. So some of you maybe for some of you it may be the little bit repetition, but I'm just giving you the concept in order to proceed further. So AI, if you have, you know that in data analysis, AI has a major role, right? So for decision making, right? So earlier, a few decades back, right, if you go, right? So AI was dealing with the expert systems, rule-based systems, logic-based systems, right? Fuzzy logics were there, first-order logics, right? And there were some probabilistic inferences were there during those times. Then later on, statistical machine learning came into picture, statistical methods like regression and other models modeling the data, right? So few models came into picture, and now that's basically the field basically expanded, right? And it expanded, and it's very big in some sense. So the field basically evolved to machine learning, right? So AI is a big umbrella. So many type of decision making was there in AI. Then machine learning evolved from AI, and the deep learning is also one sort of machine learning or AI concept in the deep learning, where we are focusing one sort of model, which is basically which exploit the structure of uh, basically massive parallelism. So that is basically deep layer architecture. So and mostly the basic standard model that we use in deep learning is the neural network, right? So neural network with many layers. So maybe you can say more than 5 layers, 10 layers, 20 layers, 50 layers. You can call it deep layer, and that architecture be exploiting the deep learning. And these terms and the users are very so these basically models, these algorithms, these approaches are very popular in the modern day. And this is not only the concept that they are popular, so they are successfully applied in many fields, right? And they are doing well in decision making. So that's the reason in every field, starting from the industrial revolutions, industries, medical domains, maybe you can say some social media, and maybe product development. So everywhere you can just see the concept, or you can say the application of AI, ML, and DL nowadays. So this is you can say the need of today's need. People have to build a smart system, automatic decision making systems. So sometimes it may not replace the human. So in addition to the human, so these machine models basically these are the AD in some sense. So they are giving some assistance to have a good decision making, right? So idea in data analysis is that you have a data. So actually the data is in whatever data you receive. So that data is in raw format. So maybe suppose I say that can you crawl the data from social media platforms, maybe WhatsApp or Facebook or maybe Instagram. And now, can you tell me the sentiment of a particular user, particular person in that particular data that you have crawled from various social media blogs or social media platforms? So what will you do? So your data will be simply in the text or image, or in the case of in the form of audio, right? And now this data is raw. So you have to somehow pre-process the data so that you can do some mathematical operations on that data. So you have to pre-process data, and the concept is that the algorithms are the approaches that we deal in this AI or ML or even in DL. So they need a structured form of data in some sense. So even you can say that vector representation. So each data points is represented as a vector, fixed dimension vector. So in that representation, you have to basically transform your data. And then after that, what you do, you just deploy. So a lot of AI models are there, lot of machine learning algorithms, deep learning algorithms are there. You uh, uh, just use your data in order to just train those models. So those models are basically capable of extracting the pattern in the data, and they can do the future inferences. So in the real time, what happens if you have a model, that trained model, you can say that is a AI concept, or you can say AI module. And once real data comes, so real data, please here I would like to tell you that this real data should follow the distribution of the training data on which your model was basically trained. So that's why we are focusing here. Even Professor Sharma told that data we have to analyze, and Otherwise, data data is of no use, right? So here I'm just adding one thing more, that so data should follow some distribution, and so the real data that is coming, right, that you want to analyze in future. So your training data should follow that, should basically represent those distributions also. Then your model will be able to generalize well, and you can deploy it in real time. Otherwise, what will happen? It will give you, this is very lossy thing, right? So very big loss may happen, right? So suppose you have a model, you have trained your data and you have a data and you have trained your model, and now suppose you want to deploy this model on some of the planet in order to get some information about the weather or about the environment there, and your model is not sufficient well to represent the distribution. So what will happen real time? You will see that your model will be doing here and there, so some random things it will be going to infer. And then you know that the cost of deploying any model on some planet, right? So that is very costly process. So if your model is not working well, it is not generalized well for the real data, for real scenario, then that model is of no use, right? So there are few methods which basically try to get the goodness, or they can basically verify the model. So generally they try to split your data into training, validation, and testing parts, and it is assumed that your test data is from the same distribution, but so test data should follow the real distribution that you want to basically uh, use in future for decision making, right? So that's the idea here. So in mathematical mathematical point of view, you can say that so this AI model is nothing but this is a function, some mathematical function, where you are giving input vectors, or you can say in some sense tensors you are giving as input, and you are getting out some output. So based on the output, you are basically going to decide something. You have to perform some sort of actions, right? So that's the intuition for this slide. So this will happen. So this same scenario will happen for influencing in all the domains. So whether it is bioinformatics domain, it is medical domain, it is in industrial application, it may be some sort of product development, right? And even in social media platforms, even maybe for learning also, some and some sort of different sort of security or defense organizations may be using these models for decision making. So there are a lot of domains, and there are many successful applications till date, right, which basically motivates everyone and every domain as well in order to deploy these AI based concepts and approaches in order to solve a complex and big and complex problem. So we have already discussed this point that you have a raw data in your hand. So your task is to basically represent your data into vector form, so that the mathematical model that we are talking about, the AI model. So AI model is nothing but, so this is an algorithm, right? So you have a data, and from the data you have to formulate some of the problems that you want to solve. Maybe classification problem, maybe you can say regression problem, maybe you can say translation problem, right? You can say document summarization problem. So a lot of problems you can just you have to have some algorithm which basically takes the data in vector form, and it basically accordingly it analyze it. Basically analyze means it basically update its parameters. So each model has some parameter. So those parameters are basically learned during this training process, and then your inferencing is done at the later stage. So data is a very important task. So, and here the deep learning basically plays basically big data basically plays a very important role here. So the concept in the big data. So first thing is data you have in your hand. You have store your data somewhere, or you are getting the data online, or data is streamed. So the first step is you have to clean the data. So cleaning the data is basically in some sense you can clean the data means you can remove the noise. So if some noise is there in the data, you can remove it. For example, suppose you have an image data and image is blurry, right? And the noise in the image is basically induced by the source or from the source, right? Then you can use some technique, some filter in order to basically enhance the image, and you can basically remove the noise. And sometime what happens if you are receiving the data, if you have data and you have missing values. So in the data, for example, if you are uh, getting signal data from some, you are receiving some signal data from some sensor, maybe for a short time or short period of time, you may not get any values for that signal. So you have a missing value in the data. So how will you curate? How will you basically solve this problem of missing value? So this is a very challenging task. Even nowadays also people are doing some research in this missing value, because so there are three things. One is either, so majorly two approaches are basically used here. So for missing value creation, one is you can impute some value, right? So for imputation, what you can say that you can say that, okay, you just put 0. So whenever you see missing value is there, you just assume it 0. Or sometime you can just see the other values in that particular feature or in particular attribute, and then you say that, okay, you just uh, get the mean and variance, and you just assume that the feature belongs to some distribution. And generally people use the Gaussian distribution, and they sample the values for that particular missing value and impute that value. So that is one of the way in the impute approach. And the third one, or you can say majorly the second one, is basically the learning process. So you may have some, you can develop some learning algorithm. You can use AI based techniques, AI models. So whenever I say AI model, so AI models means some algorithm, learning algorithm. So in order to basically impute that missing values, maybe expectation maximization based approaches, or maybe simply regression based approaches you can use in order to have a missing value. And then you have to represent your data into the vector space, or you can say vector representation, where each dimension in that space representing the features of the data, features in the data, or you can say attribute in the data. So in the database domain, we generally call it attribute, but here in machine learning, AI and DLB use the term feature, right? So we call it feature. So you have a sample, you have a data, and now you have curated it. You have removed the noise. You have curated the missing values. So, and the hard way is also sometimes people use. So whenever a particular sample or particular feature has missing values, you just discard that feature, or you can say discard or remove that sample. But that is basically lossy process. So it may incur some big loss to the model for generalization. So that is basically prevention is better than cure, right? So whenever you see missing value, you just discard that sample. So this is okay if you have a large number of samples, right? If you have enormous amount of data, then if you are removing some 10% samples, 20% samples, suppose you have 1 million samples or may have 10 million samples, and out of 10 million samples, if you say that 1% samples have missing values, then it is basically good to remove those samples which has basically missing values. But you just assume the scenario. So mostly in the medical domain, suppose you have only 100 or 200 or 300 samples, right? And you have 10% missing values. 10% sample has missing values. So removing any one sample in that small data, right, where you have a small number of samples, so removing one sample is very costly thing for the future, right, for the generalization accuracy, or for the point of generalization. So that's the here the challenge. So if you have a small number of samples, then curation of missing value is a very important thing, and you have to come out with some of the approaches. You have to use some of the approaches which basically cure it. And then if you have a small number of samples, so you can do data augmentation. Sometime Because if you have a small number of samples, so 100 samples, 200 samples, or 300 samples, even up to the 1,000 samples, so they may not be able to represent the distribution on which you want to deploy basically the real data on which you want to deploy a model. So may not be so 100 samples, 200 samples, 300 samples may not be sufficient in order to represent the distribution of the real data, right? So that's the reason there are many techniques in which you can increase the samples, right? So that is called data augmentation. What you do, you just say that, okay, your features, I'm just giving telling you one or two approaches generally people use. So just say that, okay, your data, let your feature follows a Gaussian distribution, right? So what you do, just get a distribution, Gaussian distribution, and you just sample new values. So you just sample new values and create and generate the samples, right? So just sample few values, sample the values from the distribution, Gaussian distribution for each of the features, and you just basically embed in the samples and you just increase the data. So now you are increasing the data as many samples you want, you can augment your data, right? The other way is basically sometimes suppose you have image data. So sometimes people do some rotation scaling, maybe rotation at different angles, right? Maybe flipping, so horizontal, vertical flipping. So but for all the tasks it is not allowed, or it is not advisable sometimes. For example, so there I'm just giving you two scenarios. One is, suppose you have X-ray data and you have to just detect the whether the X-ray is basically X-ray data or X-ray image data is infected by COVID or not. So this is one of the problem that you have to solve. Then another model is that, so given an image, you have to just tell whether this particular image has dog or cat. So there are two scenarios. So both the cases you have image data and you have only the binary classification, or you have to take the binary decision whether a particular thing exists or not. So for example, in case of X-ray data, so you have X-ray image and your task, your model should say that whether the X-ray image is COVID-19 positive or negative. In the other case, you have to just detect whether the image contains a dog or cat. So if you are doing the data augmentation, you just see the scenario in the X-ray data. If you flip the X-ray, right, image horizontal or vertical, what will happen? So the location of the basically particular disease, or you can say location of the organs in the image may change. May change their locations. So you cannot say that this particular location, or where the basically where the lungs are there, where the basically kidneys are there, and where is the other organs in the image. So that may be the challenging part. So for prediction, but in case of just a dog and cat, if you see, right, if you are flipping it, so that is basically not changing the decision, right, whenever you are flipping it, right? So that basically maybe sometime improves your basically representation for the real time, right? But in case of medical data, most of the time the flipping, or you can say rotation, may not be fruitful. So there may be some other techniques, other approaches which can do the augmentation. And one very popular augmentation technique is nowadays, that is again through the learning only. So that is called generative models. So generative sampling models, for example, generative adversarial neural network, or you can say variational autoencoder. So these basically models try to basically get the distribution of the input data in some sense, or real data. And then once you get the clear, or you can say right distribution of the real data, so as many sample you want, you can sample from that particular distribution. So that's the idea for data augmentation. And then if it will be good if you are able to visualize your data. So many problems if your data is blurry or noisy, many things you can get intuition, and you can apply the techniques or apply the methods in order to better represent the data, right? So data visualization is also one of the area where people basically work in data analysis. So that if you are able to visualize your data, then it's good. Sometimes if your data is represented in high dimensions, so you know that data visualization beyond 3 dimensions is complex process, right? Not very easy. So sometimes what people do, so they basically lower down the dimensions of the data using some maybe principal component analysis, factor analysis, or you can do some feature selection type of approaches, and then you just try to visualize your data in 3D or 2D, right? Accordingly. Then there are many machine learning models, and once your data is represented in vector space, you can deploy any ML model. And then there are a lot of challenges with the ML models, so that which model will you use. So in the today's discussion, we will try to make you understand that in which scenario, which model is basically you're going to basically use, or you would like to choose, right? So we will going to discuss in a moment. So data for data, we have already discussed it. So I think we have already discussed it. So this is the basically data generation. So this is user-centric approach where users are basically involved in data generation. So you know that everyone of us basically generating the data, right? So we are basically connected with WhatsApp, Facebook, LinkedIn, other social media platforms, Instagram, and others. And every day, right? So we are generating the data, enormous amount of data. So you just imagine a scenario, right? For everyone is basically generating the data, then you can imagine that what will the volume of data. So these social media platforms are basically getting or receiving the data maybe in many terabytes, petabytes, right? Even in a week, even in a month, right? So they are receiving petabytes of data. So there is a challenge that you have to store your data. So mostly the data nowadays are stored on cloud platforms, right? So cloud platforms, you have a cluster of systems, cluster of storage, and your data is stored, right, on those clusters. And physically they may be located at different places, but virtually you are not aware of those places that where your data is stored in that platforms, right? So this is user-centric view of data generation. Then in many even if you see that we have enormous amount of data in many of the domains, for example, social media, basically platforms, and maybe some blogs and others, you may have in product reviews, you may have large amount of data. But whenever we come to medical domain, so we face the problem of data, right? So we don't have sufficient amount of data for most of the tasks, right? So even for COVID-19, if you want to build a model for COVID-19 detection using the X-ray images, so you may not get enormous amount of data from different countries, right? So even in our India also, we are not able to have lot of data regarding this COVID-19 X-ray images. So the same thing is happening for all most of the problems, right? Most of the diseases. So hospitals. So the challenge. What is the reason behind this? So the major reason is anonymity and the privacy, basically. So the algorithms is basically anonymize the data. So earlier it was not digitally. Basically, the data was not on digital platforms. So most of the data was in the ledger books, right? But now many of the hospitals, even in India, they are just storing their data digitally on the digital platforms. But the challenge is that anonymity. So how will they going to basically analyze, anonymize the data so that the privacy information is not somehow compromised, and then they can basically put on the public domain. So this part is basically not adapted well till now, but yeah, there are many hospitals which are basically trying to basically adapt those things, anonymity clause and privacy issues, and few data is available, but I'm not saying that every hospital is doing that, but yeah, of course, but there is people are moving in that direction. Okay, so this is a model centric, where your model, you have a sub model and your model is able to generate the data. And once you have a data with you, enormous amount of data, and you can build a model, which can basically work well in the real time. So that is basically we call it the generalization performance. So generalization performance will be good for the model, right? So so we have already discussed few things, few challenges like missing value, noise, and another challenge we have discussed, that the number of samples. So few domains we have a very small amount of samples or less number of samples. For example, in bioinformatics and medical domain, we have already discussed. And at the same time, you may have data which can be represented in many dimensions, right? Which can have many features. Maybe gene expression data is one of the example in that case. So where you have thousands of features, but number of samples are in few hundreds, right? So if your data is small and number of dimensions are very large, then there are few challenges which basically incur during the training process. And generally people call it bias and variance problem, or you can say that overfitting and underfitting scenario. So we will discuss in a moment, right? Then in computer vision, we have already discussed that noises from sources, multimodality, maybe from different sources you have received the data from IoTs. So you may have missing values. Then in NLP also, so you may have a noisy data. So how can you get a noisy data in NLP? So you know that if you are crawling some social media blogs, maybe Facebook, or you are crawling WhatsApp, right? Or Instagram or any other social media blogs like the academics, so LinkedIn and others. So you will see that many places you may have different form of words, right? Many sentences, they may have the content from different languages. For example, in Indian perspective, if we are talking about the WhatsApp data, so the sentences in the WhatsApp or the communication that we are doing in the WhatsApp, so sometime it is basically mixed of languages. Maybe Hindi and English words we are mixing, right? And you have seen even many of us are doing the same thing. So so instead of writing the pure sentences in the English, so there are two things. One is we are using the short words. Sometime if you write a please, so instead of writing PLEASE, so we are just writing PLG, right? And so these are basically short words, so short forms in some sense. We are using emojis, right? And sometimes we are using the word of Hindi and English, or you can say even Punjabi and English. Even sometimes we are using the Urdu word in addition. So that is called code mixed languages. So these are the few challenges in NLP also. So it is not that your sentence is following the one of the languages. So it may have the content from different languages, or words from different languages. And then discreteness and human bias. So I'm not going into that, describing the discreteness point of view here. So we discuss maybe later on sometime if someone is interested. Okay. So so this is a major challenge from the learning point of view. I'm just telling you about the data. So many things we have discussed about the data. The one thing I want to tell you here regarding the data is the data bias, right? So there are two things. Your model may be biased, and sometimes your data may be biased. So the reason here is, so here so there is a model, simple model for COVID-19 X-ray images at Kaggle website. I think many of you are aware of that Kaggle. So you have a lot of competition data, competition pages there. So this is basically the data from that particular model, Kaggle dataset. So here you have a COVID-19 images, and correspondingly you have a pneumonia and normal images. And your task is to basically classify the given in X-ray image. You have to classify into one of these three, right? So you have to tell whether the image is infected with the COVID-19, or it is infected with pneumonia, viral pneumonia simply, or it is normal image. So that's the data and the problem that you have. So this is the histogram distribution of these basically pixels here in these images. So the model is basically you have trained the model and data is with you. So I'm just telling you the approach. You have data and now you just you have a model with you. You just little bit reprocess it, reshape it, crop it, and you just apply the model. And once you apply the model and you have got some accuracy, and the accuracy is very good, so more than 90% accuracy was there. But when you visualize the data, so gradient visualization is called. Basically, if you see that what patterns your model has learned. So if you see that, so it was seen that during the analysis of the basically learning pattern or the model, so it has just it has seen that there is a corner. So there are some in the X-ray images, COVID-19 images, infected images. So at the corner, there is something, right? Some spot was there, and that feature was basically learned by the model, and it has not learned anything inside the image. So only that particular feature, as feature at the corner or boundary of the image is basically captured and learned by the model, and it says just if that particular thing is available at the boundary of the image, it will say that COVID-19 is positive. And that was the reason with the data. So data was good, by the way, but uh, some noise was there at the corner at the boundary of the image. Uh, so the reason here why I am telling you this, that once your model you have trained and even you are getting the good validation accuracy on your data, it is not true that you cannot say that it is going to basically do well, or you can say good generalization, or in real time it will going to perform a good task, a good prediction, or good decision making. It is not like that. So in order to get that insight whether your model is good or bad, you have to look into every aspect of the model, right? So what your model has learned. So the gradient visualization is one of the approach generally people use in order to visualize the gradients. So what pattern your model is trying to learn, what features it is trying to learn. So that's the thing here. I would like to tell you that this bias basically may have come from the sources, right? Suppose you have X-ray machine, and in some sense there was some spot on the X-ray machine, and so that spot will be always available on the images. So one thing is that in order to solve or resolve this issue is from the data point of view, you should get a data from different sources. So they and again they may have a little bit different sort of problems. So that arise from the multimodality. So, but that will be okay from point of for a point of time. You can have some images, some approaches which can basically little bit process it, and you can deploy you can deploy the training process, and you can use it for the future inferencing. So having the data with real distribution is a very important thing. What is the time right now?
So 11:57. We have 20 to 30 minutes more.
Okay, thank you. So I'm just moving a little bit quickly. So I think these concepts. So these are the basic concepts I want to tell you here. That once even you have a model, you cannot say that you have a good accuracy, good validation accuracy. You cannot say that your model is good, right? You can deploy it in real time. So unless until you have completely visualized the learning pattern, right? What sort of features it has learned, whether it has learned the bias feature or it has learned the pattern from inside the data, right? So this is the one aspect of learning. So you can choose the right model. And the types of data we have already discussed from here, that you may have a actually the raw data is most of the time it is in structured form. So suppose you have a text data, so you have crawled your social media blogs, you have data in unstructured form, so text. So here the second one, so the text, audio, image, and video. And I have already told you that the models that we use in order to do decision making or training or learning, so they need data in structured form. So most of the data they need in a structured form. Even uh, uh, sometimes people say that okay, the deep learning models basically uh, you can deploy, you can put the data in unstructured form in the deep learning models, but it is not exactly true, because you have to represent your data into the fixed dimension representation and fixed vector representation or fixed size tensors. Then you have to provide your data to deep learning models, right? The thing is that sometimes people confuse that if you have a deep learning model, you have not to worry much. You just put your data. No, this is not like that. So you have a deep learning model. So what deep learning models basically doing during the learning process? So there are few layers, initial few layers, which basically try to extract some of the features from the data. So there are two ways of feature extraction. One is basically implicit, another one is basically explicit. In explicitly, you should have a domain expertise and you have an structured data with you, whether text, audio, image, or video. You just try to basically extract the features from the data. So sometime you may say that, okay, if you have image data, you can say that, suppose you have a problem of simple image classification, where you have images of apples and images of bananas. Your task is to just predict, given an image, you have to just tell, our model has to tell whether the image contains banana or it contains apple. So in that case, what will happen? Uh, so some features. So what are the discriminative feature can as a simple human or as a maybe domain expertise? So what sort of features are we basically going to look into that? So the features, you can say that color may be one of the features which can discriminate banana and apples. So human usually see the colors. Then second, you can say that the shape features, maybe the size, maybe the height, maybe the width, maybe the volume, right? So maybe shape type features you can use for discriminating between banana and apple. And maybe texture feature also. So sometime if you touch the surface of right apple and banana, so maybe texture features you can use. So these are the features. You should have some expertise, some knowledge about the data and the problem. Then you can extract these features. So this is called explicit feature extraction. So you just get these features and then just uh, for each sample, for each image, you just extract these features and you just uh, build your model, train your model. And you can, for the real time also, whenever some data comes, you extract those features and just uh, use that model or deploy that model in order to get the inferencing, the prediction. The other way is basically implicit feature extraction. So in case of implicit feature extraction, you have not to explicitly extract the features from the data. You just put the feature extraction process during in the data, in the model itself, right? So deep learning models are very popular in that sense, and mostly they are very successful in case of image data or video data image processing in computer vision. So the reason is that even nowadays in NLP as well. So the reason is that you have not to look for explicit features which need domain expertise, right? So you just use model and you just uh, put the concept of feature extraction during the learning process. So the layers that we generally use in deep learning models, mostly in the neural network, the layers, initial few layers are basically doing the feature extraction. Different sort of feature extraction we are doing during the learning process. And then final few layers, we are trying to basically learn the parameters, learn the basically in order to discriminate the objects, in order to learn basically do the inferencing, we learn the patterns. So that's the idea in deep learning. So data, of course, your data is in vector form, input is in vector representation. So the task of you have an unstructured data. So unstructured data is in raw form. So you have to basically convert your data from unstructured to basically structured form, because your models are basically only capable of dealing with the data which is basically represented in vector space or vector representation. And then there are few data like semi-structured. So you may have structured and unstructured sort of data. And again, you have to just convert them into, transform them into vector space. And then unimodal and multimodal we have already discussed. that your data may come from different sources. It may have a mixed form. For example, you have a data which is basically audio also, you have a text also, you have an image also, you have a video also. So can you so you have to first represent your data into a structured form, then you have to look for the models which can deal with this data maybe at once. All right, so they can use the text also, they can use the audio also, they can use the image also, and they can extract the features, and accordingly they can do the decision making. So one of these simple example I can tell you that maybe you say that, okay, image captioning, right? So you have an image, and corresponding to that image you have the text, right? You have some description about that image, or you can say you have a video and you have to generate the story about or you can say the text from that video, right? Or you can say some sort of audio to text, or speech to text in some sense. The another way is basically can you suppose some plot is given to you, some text story is given to you, can you build a video out of those text stories, right? So recently some news was there, some institute, right? So they developed from the text stories, they developed some video, right? So from some cartoon magazine, right? So that's the idea about the data here is structured and unstructured. So you just see the difference here. So structured data is represented in the vector form. So in vector spaces, you can see here. So most of our relational, basically our relational databases are in this structured form. So each relation is in a tabular form, if you see here. So each column is a basically attribute. Each row is a tuple here. So if you want to perform any query, you can perform here very easily. Right? Suppose you say that, okay, can you display the name of employees or name of the person whose age is basically greater than 51? So what will you do? So because your data is structured, you go to the field, or you can say the attribute age, and you will find out the filter out all the rows index whose value is basically greater than so age value is greater than 51. And once you have the row index, you just display the name. But in case of unstructured data, if you see here, the same data is let here. In unstructured form, it is written in the text form. So you have to scan the data many times, right? Maybe you have to scan the whole data in order to get that particular answer for that particular query, right? You have to search that where the age is greater than 51, then you have to store somewhere, and so on. So structured data is very easy to process, and that's the reason in relational databases we use the structured data, and you have to basically transform your data from a structured to a structured one. Semi-structured is like here, so you have some structure is some structure is present, but inside that structure you may have some unstructured information. For example, suppose some field address is here, and address is a completely text form. So some unstructuredness may be there. So this is basically JSON format data. So you may have a semi-structured one, right? So ultimate aim is to transform your data from unstructured to basically vector space representation, and then you can deploy your model. And these are the few problems that we generally solve using the AI or ML technique, even deep learning methods. So mostly in medical domain, you have a disease diagnosis, drug target identification, drug design, maybe protein interaction prediction, intrusion in defense, intrusion detection, spam detection, sentiment analysis, emotion detection, product reviews from product reviews, right? So in order to give your feedback on some product, and accordingly the company or industry, they can basically refine their products, redesign their product based on your feedback, based on your reviews. Regression problems you can solve using these algorithms, machine learning algorithms or AI algorithms. Other problems in various domains, like in NLP, you can have NLP and other domains. Maybe ranking is one of the problem. Maybe object ranking, image ranking, right? Video ranking. Then translation is very popular and very useful model nowadays. People are using, right? So this is basically very popular in social framework. If you see the translation, so machine translation we can call it. So you have a sentence in one language, you can call it source language, and you have to basically translate into the other language that is called this target language. So that is the basically machine translation. So you want to translate one language sentence into the other language, right? So you have seen, I think everyone you have practiced it, Google Translate, right? So Google Translate, you just so they have a model, machine learning model, basically deep learning model, in fact. So they have a translator for many of the languages, right? So you just put your language in one of the your sentence in one of the language, and you just try to get the translation in the other language. So you may get some sort of issues and noise, but generally for most of the cases you will get around 60 to 70% correct information, correct translation, and that is generally, if you see that, sometimes it is sufficient in few cases, right, in order to convey your message. So suppose you are visiting somewhere, some places, and where you don't know the regional languages or the local language that the people at that place are communicating. So you can just put your thing in Google Translate, and you just convert, or you can translate into their target language, and then you can show him or her, and accordingly you can get the right thing, right? Then document summarization, given a large text, can you summarize the document? Can you do summary? So suppose you have a 1 million sentences in one of the document, and suppose I say that, can you summarize that document into 100 lines, or maybe few hundred lines, maybe 500 lines, or you can say the 1,000 lines. So that is the document summarization. Maybe question answering is one of the problem, that you just provide some questions, and you expect some answer from the model. So maybe you can say that. So there are a few models available already for question answering. You just go and you just see, most of the NLP models are available at Stanford, right, libraries, right? So you just go and you just try some web-based applications are there. So you just try it out. So in question answering also, you just put some who, what, when type of questions, and they will try. So that model will try to answer you. For example, you can say that, where is River Gange? So it will tell you the complete information about that. You can ask questions like that. Who is Narendra Damodar Das Modi, right? So it will tell you that the complete information about that answer for that question. But there are many sort of questions which are basically models are not able to answer even till now. So people are doing research in that direction. Then you can say that maybe sometime you can use the AI approaches for forensic right investigations. For example, suppose you have a signature. So ML models are able to generate the handwritings also. Suppose you just provide maybe 100 documents of your own handwriting. So you can build a model which can generate the text in your pattern, or in your style. So that is, you can say that is style learning in some sense. And sometimes signature generation also, you can build a model which can generate the signature as well. So so that's why you can, the similar way you can use the machine learning models for forensic also. So they can investigate whether this is a fake signature, or fake text, fake content, or this is a basically legitimate, or you can say the non-fake content. Right. So these are the two aspects of learning. Two types of model learning is basically supervised one and the unsupervised one. So in supervised learning, there are two different things. Please note down. So there is data also supervised and supervised, and the learning algorithm is also supervised and supervised. So each data point or each sample may have labels corresponding to it. So if your data has labels, supervised information, or you can say the labels. So generally we call it label, whatever supervised information you have. So that is called label. So if your data has a label, so we call it supervised data. And if the learning algorithm here, you just see the first figure. So if the learning algorithm uses the label information in order to build the model, label information in order to basically learn the parameters of the model or build the model, we call it supervised learning algorithm. And once you have learned your algorithm, then again the similar way, you have a real data, you have a new data, and you just try to predict it, right? So if you have done explicit feature extraction, you extract the features, then accordingly you can apply the model and you can predict it. But if you have implicit feature extraction, you have not to do anything. You have a just your data in vector representation. You just input, provide as input to the model, learn model, and you get the inference or prediction. So this is a supervised scenario where label information is needed in order to train the model, in order to learn the parameters. And the other one is unsupervised scenario. Your data may have the label information, your data may be supervised, but your algorithm may not be supervised. So your algorithm does not require the label information. Then we can call it, this is unsupervised learning algorithm. And if your data also does not have label information, then it is called unsupervised data. So that's the concept. And again, the inferencing is just done in the same way as in the case of supervised learning. So you have a unknown data, you have a test data, or you can say you have a real data. Accordingly, if you have explicit feature extraction, you do the feature extraction and then apply the model, you get the prediction. And if you have implicit feature extraction, you have not to worry about your that feature extraction will be done in the model itself. Okay, so that has been trained already. So this is the aspect of learning. So supervised, unsupervised, there is basically semi-supervised learning. So that is basically your data is partially, your algorithm basically needs partial levels. So there are few algorithms which basically solve the problem of basically semi-supervised concepts, semi-supervised data. And these are the few algorithms: Bayes, linear regression, support vector machines, decision tree, random arrays, neural networks, and even neural network is exploited in deep learning, right? So the reason, so I have not discussed many of the things. So why do we use neural network only for the deep architecture, to explore the deep architectures, deep layers? So there are certain reasons about using the neural network for deep layers. Or so one is the computational aspect, that massive parallelism can be done, can be exploited. Then another one is basically the nature of the algorithm, or you can say the prediction proof that says that this is universal approximator. So any complex function, right, which is basically continuous in some domain, right? Neural network even with single hidden layer neural network is able to approximate it. So that's the theorem, universal approximation discussed about. And for unsupervised learning, you have a k-means, mostly the clustering based approaches, k-means, hierarchical, scan, autoencoders, and etc. So I think these are the few other applications like colorization, adding sound to silent movies, automatic machine translation, object classification in photographs, automatic handwriting generation, character text recognition, image caption generation, automatic game playing, and others, right? So I think now we can, if we can see if people are here, so we can take some questions. So is there any question, Professor Sharma?
Definitely, sir. Definitely, sir. Yes, we can give 5 to 10 minutes for question answers, sir. Participants, if you have any queries till sir has presented, please go ahead, and better if you can write on the chat window, because sir can have access of the same. But still, we do not have, sir. You can continue for 5 to 10 minutes.
Yeah.
If you want to go far.
Yeah. So I'm just now moving towards the so many challenges we have already discussed. So in this talk, basically, our motivation was just to discuss the challenges, not the exact method that how we are doing that. So the reason is that I think in all the days, all the 5-6 days, you will be going to learn those methods, right? Mostly. So here in this talk, my aim was to expose you the challenges. What are the challenges in the models, right? One thing I have not discussed here, that is a very major one, that is bias variance trade-off. We have just named it, but that is a very important concept in AI and machine learning. So if you want to choose a right model, right, you have to basically take care of these problems of variance and bias, right? So variance means overfitting. So if you have a model and very complex model, and it has basically remembered all the training data points and label for the training data points, and whenever it come to the real, you are deploying it into the real domain, a real scenario, it is basically, it failed to solve the problem, right? It failed to basically do prediction. Then that is the problem of, you can say, the overfitting in some sense. So mostly you can say that model is not generalized well, so that is overfitting, or this is also called the variance problem in the models. Another one is the bias problem. So sometime if your data is little bit tricky, you have some noise in the data, some basically your model is very, maybe your model is very small, very very simple model, maybe very few number of parameters you are learning, so they may not be able to generalize well that model. So then bias problem may be the issue. So training is also not well. So in that case, so your training accuracy or training error is very high, training accuracy is very low, you can say, in that sense. Then you can say that, okay, you can say that your model is performing underperforming on the training data, so it is basically the bias problem. So the thing is that you just go into and look into the data, the data which are basically misclassified or not learned well. So, and you get some insight. So there are there may be two reasons. One is your model is too simple. The another one is your data is bad in some sense. Data is noisy. Data is some sort of, if you talk about the image data, it may be blurry data. Even humans, if you feel that humans are not able to basically do the detection or some analysis, then your model also may fail in that direction. So you just curate your data in some sense, a little bit, try to basically enhance your data. Otherwise, what you do in the case of bias problem, you just try to increase the complexity of the model. For example, if you are learning the linear models, you go for the non-linear ones. Even for deep learning also, if you are learning, if you have maybe 3 layers, 5 layers, you can increase the number of layers. You can go a little bit more complex models, right? Number of iterations you can change, right? And in case of variance problem, in order to reduce the variance problem, generally what you can do, you can do the regularization. So in both the cases, I'm just assuming that you have done the right partitioning of the data, and then you just do the regularization. Most of the popular and very intuitive, and you can say the very useful concept of regularization in order to have a basically low variance in the model, right? So generally people use the regularization. And even you can, if you are learning very complex model, you try to reduce the complexity of the model. So if you are having the maybe nonlinear model, maybe polynomial degree 10 model, if you are using, so please go down to maybe few degrees, maybe 2 degrees, 3 degrees, or even you can come, you can test the linear models, right? So so both are the basically two extremes. One is basically your training error is very high. The another is saying that your training error is very small, but your validation error is very high, or the testing error is very high. So both are the two extremes. So actually the good model, machine learning model, so needs to get some trade-off between these two. So you have to have a model which has basically low bias and low variance. So we generally need a model which has low bias and low variance. So that's the idea in the model selection. So if you have many models, and another one is basically fine tuning. So you have to tune the parameters, and after tuning the parameters, you just access the model on validation accuracy, or maybe some test data if you have to testing accuracy, and accordingly you can access your model and you can choose the right model. Okay. So now I'm just going to give you the little brief about the big data and challenges. So there are two things again here. We have again the two extremes. So you have a large amount of data and you have a small amount of data. So in a small amount of data, we have already discussed the challenges that your model may be going to have a high variance problem. You have to maybe generate the data in some sense, data augmentation you need. But what will happen if you have a large amount of data? So big data means large amount of data, though it is a relative term. Maybe based on your resources, you may feel that maybe 1 million sample is a big data for you. Maybe if you have a good resource with you, you are capable of storing that data, then you can say that no, this is not a really big data. So you can say that, okay, 10 million may be big data for you, 10 million samples. maybe someone will say, okay, no. Maybe 100 GB data is big for me. Someone will say, no. Even 10 terabyte data is not maybe big for me. So we are able to handle 2 terabyte, 5 terabyte data, but we are not able to handle the 10 terabyte data on our machine. So you just see that. So little bit, this is a relative term, but even if the term becomes, so in general, if you see the term becomes, so generally if it is not, if your resources are not able to fit the data for analysis, right? So that's the one thing. And another thing is that many times, so you should know, you should have some strategy, right? So if I say that we have a one petabyte of data, so I think here, whoever is here in this meeting or the participant that we have, so for everyone, if you say that, okay, you have 1 petabyte of data, it is big for everyone, right? So so the fuzziness of the decision making about the big or small data is basically eliminated if you have a very big value, very large value, right? So the concept is that what is big data? So why do we talk about the big data? So major concept in the big data is that suppose you have a 1 petabyte data, and even I can take the little bit smaller case. You suppose you have a 10 terabyte of data, and most of the hard disks that we have in our systems, they are around in general systems. So that user we have, as a user we have, so around 4 terabyte of maybe hard disk you may have. Maybe you have external disk of 2-3 disks in which you can store maybe 12 terabyte of data. But the RAM that we have in our system is not even 1 terabyte, right? So if you want to analyze the data, what is the first step? What is the standard way of analyzing any data? So generally what we do, we have a data in our secondary storages. We write some code, some program, some script, which basically loads the data from disk to secondary storage to primary storage, maybe RAM. And if our RAM is not able, is not sufficient, right, in order to basically accommodate the data. So because in order to analyze any data, so your data should be present in the RAM, right? And your RAM is not capable enough to accommodate let 1 terabyte or maybe 2 terabyte of data. Then what will happen? So even you cannot scan data once, right? So scanning one pass of the data is a very challenging task. So what is the idea? So generally, if you see for the standard, or you can say the traditional approach, so generally people were doing that. You just split your data in the disk and just take the data, or you can say load the data, which is basically capable, which is basically RAM is capable enough to handle, and then accordingly you can process your data and you can do it. So generally, the main thing is that if you have a large data, then that challenge is here. So on the simple system or in standalone system, if you don't have sufficient RAM, so it is a very challenging task. Even you one scan of the data you cannot perform, right? Because your data is not in the RAM. You cannot load the data in RAM. So only the way that people are doing in the traditional way, that somehow they are trying to get the chunk of the data and from the disk. So they are loading a small amount of data from the disk, and they try to analyze something, and whatever information from that particular part of the data, they are just storing the small information somewhere, and then accordingly, if they scan through whole part of the data, 2 terabyte or 5 terabyte data, and then they are just extracting from each, you can say, the block size they are basically analyzing. So they are just storing only the informative things from that particular chunk, and then later on they are just aggregating the analysis. So that was the way people are doing, but of course there was a need to handle this type of data. So there were platforms. So people came up with the idea. So the idea was some platform. So one of the popular platform is the Hadoop framework, if you have remember, right? So Hadoop framework, what is the idea? So many systems basically instead of one system, one dedicated system, you may have many systems as a cluster of systems. And you can use the storages, secondary storages of those systems in order to basically store the data, so in distributed fashion. So your data is not stored on a single machine, so it is stored in a distributed environment in some sense. And during the processing, if you want to do some analysis, some processing, so you can just have, so how the architecture basically works. So in order, suppose you have a cluster of systems and your data is stored on different machines. So how will you do any analysis? So the layman, or you can say the obvious view is that some system or some person will be there, so who is basically instructing to the all the nodes that you have to perform this task on that particular data that you have with you, right? So that is basically the task of, we call it master node, and mostly in clustered or in cloud, generally people call it master node. But here in the distributed environment under this Hadoop, we call it name node, right? So name node is basically distributor, so it will give the basically instruction to the computing nodes that you have to perform this task on the data that you have, right? And so how that works, so how the Hadoop stores the data. So Hadoop stores the data in form of Hadoop file system. So Hadoop file system is a distributed file system. So if you are getting the stream data, so suppose you are, again, maybe I can just give you one exercise also, if you want you can test on your own. You just download some crawler and some API which basically crawls the some Wikipedia page, some maybe some web crawler, right? And you start storing it, and you have suppose you have a Hadoop system, so you just to do that on the Hadoop system. So and after the receiving the data, maybe after 10 minutes or 20 minutes, you just try to store it in the Hadoop file system. So what will happen, your data will be stored in different places, different nodes, right? So once, if you see that your data is stored in the distributed fashion, then there are a lot of challenges as well. So sometimes you say that, okay, you have suppose successfully stored your data, but during the processing, suppose some node basically crashes or power off, some node has the power off. What will happen? Then your system, your framework should be capable enough in order to handle these type of situation. So it may have the fault tolerant scheme. So that's why Hadoop framework basically has those things, those mechanism. So you can have the copy, you can store the copy of that data on different nodes. And in case of any failure, the other node which has the data, so they can take over on that task, right? So the task or the computation or the analysis is performed in MapReduce fashion, by the way, on Hadoop framework. The idea here is you have a data, you have a algorithm. What you do, you just some sort of sorting is done. You just say that, okay, you represent your data into key value pairs. So you say that some indexing is done. So for your data, you have to do the indexing. The reason is, why do we need indexing? Indexing is needed because you have to get the analysis, because you are doing the analysis on part, right? So this node is doing first part of the has first part of the data, then another machine has the second part of the data, and so on. So indexing is important for the samples on a particular node, right? So in order to get the analysis, right? So you have to represent your data into key value pairs, computation key value pairs. Then you have to map the computation on different nodes. So what type of computation you want to do on each node? For example, very simple example, I can say that given a Wikipedia data, maybe 10 terabyte of data, you have to just find the word count. So how many unique words are there? Or you have to just find out that what is the frequency of the words present in the data. So even on a single machine, simple system, we cannot do it because you cannot store 10 terabyte data. And even if you want to do that on a single machine, you have to develop some approaches which can basically work on the small part of the data, a small amount of the data, which is basically your RAM is capable of doing that. But on a big data system, if you have a 10 terabyte of RAM, or maybe more than that memory in that architecture, you can solve your problem, right, in one go. So what you have to do? So you have to your data is splitted and basically distributed on some part of data is stored on this node, and some another part is stored on another node. What you do on each node, you just see that whatever data is there, you just try to count how many words are there, what are the unique words, and just count it. Then what you do, once you have done, each node has performed this task, the aggregation is taking place. So that is called the reducing operation. So the task computation of this word count representing the key value and word count is called the mapping job. And then what you do, you aggregate it in some sense. So you reduce the job. So what you do, you just see that maybe 2 nodes, 3 nodes, 4 nodes. So they are just giving the result to the reducer. So and then finally the results are aggregated. So that's the architecture of MapReduce. And so this is not new idea. MapReduce was basically the researchers were working deploying this idea of MapReduce in parallel programming many decades ago, right? Even you can say from 90s, even from 20s, 2000, right? Even 90s and 2000s, people were doing the parallel programming and using the concept of MapReduce. But here in Hadoop framework, so we have also the concept of MapReduce, and on which the basically Hadoop framework we are solving the task. And mostly it was so the routines and the things was written in Java. So this Java compatible. So but nowadays there are many wrappers, many packages, many different modules on Hadoop, which works in Python as well, which works in different languages. For example, PySpark is there. There is machine learning library, mlib is there, right? So there are many things which can in different languages you can deploy on this Hadoop framework, and you can do the problem solving. So I can show you one example, maybe a little bit after. So Professor Sharma, do we have 5 minutes more?
Already we have next sessions to go, sir. Okay, 1 or 2-3 minutes you can take, sir. No issue. Please.
Okay. So these are the few things that we generally want to do with the deep, or you can say the big data. So that is capture the data, curate the data, store it, search it, maybe sometimes sharing, or sometimes maybe transfer of the data, some sort of analysis that I have already discussed, that maybe very simple enough word count, or some sort of machine learning or deep learning process you want to evolve, or you want to deploy with this data. So we have to go for some platform, some framework which basically able to handle the big data. So I'm not going into this detail that how the data basically grows. You can say that from initial days, if you go for back to the 2 decades back, so having data in MBs was a very a big task, right? You can say that even operating system, if you talk about the 95 and Windows 95 and others, so they were in MBs, right, in megabyte. Even they are not in JBs. Even the RAM that we were having at those times, so they were in few MBs. It's 164 MB RAM, 128 MB RAM, like that we had in our systems, right? So the way the data is growing here, so megabyte to gigabyte to terabyte to petabytes, now exabytes, right? And different form of data that we have, right? So I'm not going into this detail. I will save the slides. So thus there are 4 things. One is the volume of data volume. So the volume of data, of course, you see that it's increasing very high rate. So this is you can say the volume of data. So we have a large amount of data nowadays from social media platforms and others. But there are few domains where you don't have the sufficient amount of data. For example, I discussed that medical domain. Data you can get from sensors, reverse handle devices. So you have a many sort of data. So we have a large volume of data. Variety of data, we have already discussed that you may have text data, you may have graph data, you may have audio data, you may have signal data, you may have video, image data. So you have a variety of data. So different form of data you have. Then the velocity, you know that velocity is simply the rate on which we are receiving the data. So that is very huge nowadays. And then another one is basically veracity. So veracity is basically the uncertainty in the data. Many times you have a data, but sometimes you have a missing values, you have a noise in the data. So that you can say that is called the veracity in the data. So these are the basically 4 V's of big data. So volume, velocity, variety, and veracity. Right. So I'm not going into that detail. So this is the framework. I think we can skip it. So these are the models we will. So these slides I will share with the with Professor Sharma, and he will distribute it. I'm just directly, so this is the MapReduce architecture. So that generally earlier in the parallel program, what was the concept? So your data is stored on a master node, and the task was basically distributed to the cluster nodes. And we were needing the computations, right? Compute power from other nodes. So though nowadays we have this with GPUs and multi-core systems, or maybe multi-CPU systems, but in the distributed one, what is that? The data is distributed on different nodes, and compute is also on their different nodes. So master is just giving the instruction that you have to do this thing. So this is the MapReduce architecture. So in the distributed environment for handling the big data, the second one. And okay, so this is the word count problem. So that we have discussed. You have to store data here. In this form, and accordingly you have a data in your Hadoop, basically Hadoop file system, and you can perform some analysis, matrix multiplication, and there are many routines are there already available. You can just go and you can solve it on your own. This is the basically last I'm just coming. So there are many slides, I have skipped it. So this is the architecture we have here at IIT Jammu. So I'm just moving to the big data architecture. Yeah. So this is the big data framework that we have at IIT Jammu. So we have a two name nodes, master node, and we have a job tracker node, and these are the basically slave nodes. You can say the compute nodes. So we have a 6 CPU nodes, and we have a 3 GPU nodes where we have a V100 Tesla V100 GPU, right? And 6 GPUs we have on our big data framework. And around the compute power that we have, we have a 360 cores, computing core, and GPUs we have that, and that memory that we have, that 6 terabyte of RAM, and we have a GPU memory of 1.92 terabyte. And CPU compute power we have around 30 teraflop, and GPU compute power we have around 42 teraflop on our big data framework. And if someone is interested, sometime if COVID guidelines basically permits, sometime you can visit our campus and we can show you that this particular platform here at our place, right? And we have a secondary storage here. You just see here we have a 864 terabyte of SSD, and we have around 18 terabyte of SSD on our big data system. So in total, including HPC and others, we have around 800 teraflop compute power and 2.25 petabyte of storage. Yeah, so thank you. I think we do not have sufficient time, otherwise we can have some demonstration. Yeah, thank you. Thank you, Jan, and I'm now ready for the questions.
Thank you very much for your detailed lecture. You started from the machine learning and deep learning, and then you moved to the big data analytics. Definitely, it was fantastic overview to all the beginners who are working in the field of the data analytics. Although I have worked a lot in big data analytics, sir, I have worked on Hadoop, Hive, and Kafka, and real-time scenario I have worked a lot. So I generally I do feel a lot. I mean, we faced a lot of problems. Earlier, I was using Cloudera on my machine to run the Hadoop. But after the COVID, everyone became smart, and Cloudera people, they also became smart, and they made it paid. Earlier, it was free. So so then I use HDFS Apache Hadoop, which is open source for installation, and then working on various word count program, creating directory, moving file. So it's very complicated. Or you said rightly that it doesn't mean it takes a lot of time when you install, and when you start the things, it takes a lot of time. It's not easy to complete the things in 1 hour or 2 hours. You are very right. Rightly said. So definitely,
thank you, Professor Sharma. And I will be happy if you visit our campus, and
yes, sir, because
we can discuss many things.
Because the infrastructure you told, that's definitely very good, and we can utilize this for real-time data analytics. Because upcoming day we have abundance of data. We cannot keep it on a one machine and then transfer to the different blocks like in HDFS we are doing. We will be doing it really in a real time using the Kafka.
That's the only the current scenario that people are using. Otherwise, you cannot, because for storing we need this platform, right? Yes. So if you have already stored your data, then You have some traditional approaches which can work on the part of the data, but so that is a very challenging task, right?
Very challenging, very challenging, no doubt, sir.
This was the only reason that you said that Cloudera and many of the publicly available platforms, so they were now paid, right? So maybe they give you some sort of initial free uses,
you're
but
right,
maybe later on they are going to pay. Even in Google Cloud also. Yeah.
Same. You're right, sir. You rightly said. Even the various LMS like Moodle and Moodle Cloud, they were all free, but now they are paid because of the storage capacity.
That's the reason. Please. We can get questions from participants.
If you have query, please go ahead. Please go ahead. Sir is there to respond. Although it was a very lengthy session, because things cannot be completed in 1 or 2 hours when you talk about the big data analytic, as the sir rightly said. And thanks for being with us, participant. Thank you very much. If you have any queries, please put on the chat windows. And I think Dr. Arun can see on the YouTube. Dr. Arun can see the YouTube live channel if there is any, and they can talk to us. They can share with us.
I think some question is here.
Yes, sir. Only one question from the participant. It would be better if you could explain the entire procedure with a single example from research.
Okay.
Or you can just share some reference material or some links so that participants can access it at some other point of time.
So one thing I want to tell you that the concepts behind the deep learning, and nowadays if you see the successful story, a lot of successful story about the deep learning approaches, and many places if you have a large amount of data, people are deploying the deep learning models. The basic concept or the learning procedure in the deep learning is the matrix multiplication. So matrix multiplication, or you can say the tensor operations, are the basically backbone of the deep learning models. If any model, any architecture is exploiting that tensor operations, or you can say mostly the matrix multiplication, so that is the very fast and efficient framework for deploying and you can handle the even very big models, right? So the challenge again here is if your data is in petabytes, terabytes, even in exabytes, so how can you deploy the deep learning models? So you know that the major challenging part is the matrix multiplication. So if you have a model and if you have a routine which is basically able to do the sparse matrix multiplication on these big data distributed platforms, then you can basically proceed in that direction. You can use your deep learning algorithms on the large, or you can say the voluminous amount of data, right? So please note down, if you are going to do research in this direction, then you have to look for the platform or distributed platform which can do the matrix multiplication. That's why here I have written one script for the matrix multiplication also. So you can get online also. So there are a lot of scripts available which can do the matrix multiplication on Hadoop platform, right? So and nowadays even this is not very old, right? So only I think 2-3 years or 4 years you can say that people are deploying a lot of packages in order to handle the machine learning for big data. So big data is so deep learning is not by the big data. So deep learning is one of the learning method or approach which can basically learn deep layer architectures. Big data is different. So here you have a enormous amount of data. So you have to basically learn some pattern from that data. So big data plus AI algorithms, if you want to pursue research in the direction, that may be one of the recent or you can say development you can do in this direction in the area. But traditionally, if you talk about the deep learning or AI or ML model, so any problem you can take. So very popular problem nowadays, COVID-19 prediction. So maybe you can take this data and you just try it out your own. So lot of packages, lot of algorithms, lot of steps are available online nowadays. You have not to pay anything for that. So maybe you just choose any of the problem that you want to solve, right? And you just see that only the thing is that you have to come up with some idea which can map your problem to the learning problem, right? And there are a lot of learning packages, learning model available. You have to just process your data, pre-process your data in some sense, represent your data into vector space, vector representation, and you can deploy the models and you can assess that. And if you want to go deeper into that, of course, you have a problem in your hand, and accordingly you have a lot of things. You have to do the courses maybe on AI, ML, and deep learning. So this is not a thing that we can discuss everything in this 1 hour span or even in 2 hour or 3 hours span. So it may take, if we describe one problem and go into detail and even the experimentation, it may take maybe more than few hours, right? Maybe you can say 3 hours, 4 hours, 5 hours, something like that. So I think with this intuition, please try to solve any of the problems. So suppose you say that you have some problem, maybe social media platform, you want to do sentiment classification, or you can say you want to find out the review sentiment about or mood about some product reviews, or even in movie reviews. So you can start working on this, and lot of codes you will get. But you can start on your own and you can try it. You can do in music if you are interested in music, right? You can start music generation, right? So you can generate music using the AI models, right? You can suppose you want to develop some face recognition system. You can do face recognition. You just collect the faces and you just try to deploy some model for face recognition, right? So there are a lot of problems, and each problem has a research perspective. So you cannot say that only can be used this problem or that problem. So any problem that you have interest, you can start working on that.
Definitely, sir. Definitely, you're right. And in addition to your answer, one thing more I would like to add to the participant are the researchers who are keen in big data analytics. Make sure they have a good platform, like they have a good tie-up with IIT Jammu, like because infrastructure we need is very high. Otherwise, if you are using your own laptop for running this HDFS, it will take 45 minutes to 1 hour to get it started. Meanwhile, it crashes, your resource manager doesn't work, your node manager doesn't work. A lot of issues may come. So make sure we have a good collaboration with a good with the institution where we do have a hardware for the same. That is also the need of. So thank you very much, sir. Thank you very much, sir, for your glimpse into the things which is there in big data and things which we are supposed to. And definitely you're right, because if we talk about the hands-on on all that in big data analytics, it's not easy in 1 or 2 hours. It takes 45 to 1 hour for Cloudera to start, or even the HDFS, and sometimes it crashes. It's of no use. So we will in future keep in touch with you, sir. Once again, on behalf of Department of Computer Science, Vadava Campus, University of Jammu, and Teaching Learning Center of Ramajun College of Delhi University, Dr. Arun Agrawal is a counterpart here from their side. I welcome you once. I thank you once again for your kind acceptance in a very short span of time to agree and you for this talk. And really, in future also, we will keep in touch with you for more. Your insights into the big data and the collaboration we will be looking into for research and all other things. Thank you very much, sir. Thank you very much, sir.
Yeah, thank you, Professor Sharma and Professor Agrawal and your team. Thank you all the participants. So thank you everyone. Yeah, bye.
Sir, thank you, sir. So we will